This is problem number 1 from today's warm-up problems. Part A asks us to multiply these two cube roots together. We are allowed to multiply or divide roots as long as their index is the same. This is a cube root and a cube root. So I can multiply these. And to do that, all we do is multiply the radicands. So the cube root of 6x to the 8th times the cube root of 4x squared is going to be, that is a big old fat 3, the cube root of 6 times 4, x to the 8th times x to the 2nd. And then we reduce this root. The cube root of 24 does not come out even, so I want to try to find a factor of 24 that's a perfect cube. That would be 8. 8 times 3 gives me 24. The cube root of x to the 10th, you can check to see if it comes out even by dividing 10 by 3. It does not, so we want to split up x to the 10th so that part of it comes out even and part of it does not. So we're dividing by 3. The biggest number that is smaller than 10 that is divisible by 3 is 9, x to the 9th times x to the 1st. And then we reduce the ones we can. The cube root of 8 is 2. The cube root of x to the 9th is x to the 3rd. And the ones that don't come out even stay under the root. So we've got 2 x to the 3rd times the cube root of 3x. Extra long root. Part B, we could rationalize. I would suggest trying to divide first. If you can divide and then simplify, it's going to be easier than rationalizing. So on this one, 108 divided by 2 is 54. X to the 5th divided by x to the 2nd is x to the 3rd. Y to the 5th just stays as is. And now we can simplify. We're looking for a factor of 54 that's a perfect square. 27 is a perfect cube. 27 times 2, 9 times 6. 3 divided by 2 does not come out even. We're going to split up x cubed into x squared and x. 5 divided by 2 also does not come out even. We'll split that up into y to the 4th times y. Final answer then, 3. 2 divided by 2 is 1, so x. 4 divided by 2 is 2, y squared, times the square root of the ones that did not come out even, 6xy.